Wallet login doesn't have to replace your existing app architecture. In this section, we'll treat it as another authentication path, one that connects to the same backend, user accounts, sessions, and records your web apps already rely on. So far, we've covered the core pieces: blockchain ledgers, authentication concepts, public key identity, wallets, seed phrases, and message signing. Now we'll connect those ideas into a real login flow, where a wallet signature becomes a session your app can use across users, APIs, and databases. The core challenge is translation. A wallet can prove that someone controls a blockchain address by signing a message with the private key. But most web apps need more than an address. They need an internal user ID, profile fields, permissions, preferences, and a session cookie. The backend acts as the bridge. Verify the signature, map the address to an application user, and issue the familiar session the app already understands. A wallet login keeps two responsibilities separate: proving wallet ownership and maintaining a normal application session. The app first asks the backend for a fresh nonce, then asks the wallet to sign a human-readable message that includes it. The backend verifies the signature against the claimed address and confirms the nonce has not been reused. If everything checks out, it links or loads the user record, then issues a cookie or JWTs for regular authenticated requests. In most apps, the wallet address should be treated as a login credential, not as the person's entire identity. Keep a stable internal user ID, then bind the user's primary wallet and any additional wallets to that record. That user record can own roles, profile data, preferences, and future sign-in methods. This avoids painful assumptions when someone rotates wallets, uses multiple wallets, or later recovers access through another verified method. Designed for that flexibility from the start, the internal user record should be the stable account, while wallets, email, and social logins are linked authentication methods. Each linked identity should store its provider type, address or identifier, chain when relevant, verification state, and timestamps. With that structure, a user can add a second wallet, switch to email recovery, or migrate login methods without changing authorization rules, because permissions still attach to the internal user. The pattern is simple. The wallet proves control, but the backend still owns authentication. The user shares a public address. The server returns a one-time nonce challenge, so old signatures cannot be reused. The wallet signs that exact message without exposing the private key. Then the backend verifies the signature, connects the address to a user record, and issues the normal session your app already understands. After the signature is verified, treat it as the login event, not something to repeat on every request. The backend should issue an authenticated session, usually through a secure cookie or a JWT. Cookies fit browser apps well because the server can manage state and revoke access easily. JWTs work well for APIs and mobile clients because they travel with requests. Either way, define expiration, renewal, and logout. Clearly so, access stays secure and predictable. From the user's perspective, the app should now feel familiar. Each protected request passes through middleware that validates the session cookie or JWT. The backend loads the internal user record and exposes a current user object to pages and APIs. From there, authorization is a separate question. What is this user allowed to do? The wallet proves identity at login, but your app still enforces access through normal backend checks. Hybrid authentication works best when every login path resolves to the same identity. A user might start with a wallet, later add an email magic link, then use a passkey for convenience. Your backend should treat those as linked credentials, not separate people. That requires clear account linking, consistent UI language, and safeguards against duplicate profiles. The goal is choice for the user, while the product maintains one secure, recoverable account. Account linking prevents one real person from becoming three separate users. The safe pattern starts from an authenticated session, then asks the user to confirm the new login method they want to add. Next, the user proves ownership, such as signing with a wallet or verifying an email. Before linking, check for conflicts or existing accounts. Finally, give users clear settings to review, remove or add identities, and keep an audit trail for security. Once the signature is valid, authentication is finished and the backend switches to user state. If the wallet address already exists, resume that account immediately. If it is new, create a user record and begin the first-time experience. If the account exists but profile details are incomplete, continue onboarding after login. This separation keeps wallet login fast, while still giving the product room to collect preferences, profile fields, or compliance information later. A smooth wallet login reduces uncertainty at every step. Start with an explicit Connect Wallet action, then show the shortened address so the user knows which account is active. Before asking for a signature, explain the purpose in plain language. This proves ownership and does not move funds. Treat errors as normal paths too. If the user rejects, lacks a wallet, or is on the wrong network, give clear recovery guidance. Production wallet login is only trustworthy when the surrounding operations are solid. Treat every nonce as single-use and short-lived, so old signatures cannot be replayed. Once authenticated, protect the session with HTTP-only, secure, and same-site cookies. Record the events that matter: successful logins, failed verifications, wallet links, and logouts. Also, plan for messy realities, like users changing wallets, losing access, or creating duplicate identities. These basics turn a demo flow into a dependable production flow. The takeaway: wallet login does not replace your web stack. It proves wallet ownership, links the wallet to a stable user record, then relies on sessions, tokens, and protected routes. From there, wallets can coexist with email, passkeys, and social login. Next comes authorization, roles, security, and privacy.